Our next speaker is hailing, I don't know if it's like technically Microsoft CISO's office or...
Yeah, it's the CISO. It's a CTO org within the CISO org.
Yeah.
So
some folks may be familiar with CISO, and then deputy CISOs would be John Lambert, so of fame of Attackers Thinks in Graphs and Defenders Thinks in Lists. Diane, and last year at Graph the Planet, John gave a great talk of, I'd say, the vision of where things are going, but then somebody actually has to make it real. And so enter Diana.
Great intro. Thank you, Leo. Hi, everyone. My name is Diana. Like Leo mentioned, I do security research and AI engineering work at Microsoft, so tons of different projects spanning from reinforcement learning on security telemetry to creating, kind of orchestrating red teaming agents, blue teaming agents, different types of security agents. My special niche is enabling these different agentic systems with different types of security knowledge graphs. Whether or not that's like posture graphs or activity graphs. So today I'm going to be sharing some new functions that we open sourced from my research org with Ron and John Lambert. John, like Leo just mentioned, has this famous quote that's something along the lines of, attackers think in terms of graphs and defenders think in terms of lists. And because of that, attackers will always win. And so a lot of the core of these functions is the intent of these functions is trying to enable defenders to more easily create and think in terms of knowledge graphs, because it turns out creating knowledge graphs is not a super trivial thing to do. And so, this is Graph the Planet. I'm sure lots of members of the audience already know the power of the graph data structure to solve tons of different problems across different industries. But just quickly spinning off, knowledge graphs are super powerful. They help make implicit relationships explicit, which helps empower humans, but also AI systems. A lot of relationships that humans, whether or not they're aware of it, they have in their head. Sometimes making that explicit for AI systems can be pretty beneficial. There's tons of really fancy graph algorithms that you can run on top of knowledge graphs, GNN stuff. There's edge prediction. There's also tons of operators that you can only really, there's tons of different types of questions that you can only really ask with graph operators that you can't really ask in the relational or tabular world. In the relational and tabular world, you're limited by where clauses and selects and projections and summarize bys, but maybe you want to ask questions that you can only really ask with graph operators like pathfinding or blast radius or node centrality and things of that nature. And so there's tons of graph applications already happening in security, as most people are really well aware of. There's posture graphs, there's attack graphs. This is kind of like your bloodhound type thing. Reverse engineers are using abstract syntax trees for research. The core of this presentation is really going over number 6, activity graphs, so knowledge graphs that are created from your security logs. Oh no, oh sweet. Yeah, thank you for fixing that, thank you. Don't want to lose the remote, folks. All right, beautiful, thank you. And this is really important because activity logs are how we see threat actors. Everything that we know about threat actors in Microsoft, we've learned through security logs. The way you know you're getting hacked is usually through security logs, and this is where a lot of SOC analysts are currently living in. So if we give a security analyst a posture graph or an abstract syntax tree, they don't really know what to do with it because they're lost in the weeds of security logs, and that's how they see the world. And so even in security logs, there's some graph nature to this. I think there's been some excellent presentations essentially covering this topic earlier today, but every single security log has a graph just waiting to be pulled outside of it. There's nodes, there's entities that have different relationships between them. I might look at a security log and see IP addresses that are requesting auth to particular users with particular passwords. And it turns out that there's multiple ways of modeling just one row of data. I might look at this sign-in log and see these relationships in this graph structure, but different analysts might look at it and see and pay closer attention to the device or the host name of this authentication log. And so even from analyst to analyst, or even myself when I'm investigating things, sometimes when I look at some logs, I see certain relationships in certain entities. Versus other investigations, I might pay closer attention to the user agent, something of that nature. And so it turns out for security logs, there's a lot of kind of opinionated modeling. The modeling is a lot more flexible and manual and malleable it's very hard to get one security knowledge graph modeling to rule them all with activity logs, especially because analysts are also really opinionated about how they see the world through their data. And we don't really want to make them change how they see that. And so historically, a lot of the work in terms of creating these activity graphs is kind of flown through, like, you start at your relational kind of tabular database that you already have. This is like your Custo, your SQL, like your log telemetry, and then you cook it and bake it through ETL pipelines and turn it into like into the knowledge graph data structure. And then you store that in a separate kind of copy, as a separate copy in a graph database. This is like your Neo4j, your Tinkerpop, your Custo graph, et cetera, et cetera. And there's really elegant ways of doing this to make this efficient, but it's very kind of resource intensive. You have to store a copy of every single network event, and it tends to get pretty expensive pretty quickly. And so for the purposes of this presentation, we're really only focused on making kind of temporal, ephemeral investigation graphs that have just the amount of data you are looking at for your investigation. So analysts and AI systems can spin up kind of temporal, ephemeral investigation graphs right kind of at the layer of the relational and data tables that already exist in your system. And we're trying to keep it as like granular at this level. So analysts can render these graphs from this layer, because it's really challenging to orient yourself around a graph that you didn't create yourself, that's been cooked and baked a bunch. Like analysts are super, they're very much experts at the relational and tabular world. They know that data and that schema in and out. Making them kind of process and understand a graph of data that's been cooked and relabeled and all of that stuff can be challenging, versus like keeping them at the layer of data that they're at and enabling them to have just the right functions and operators to kind of spin up graphs at that level. And so a lot of this presentation is going to be about kind of the KQL Custo world of security telemetry. If you're familiar at all with Azure, Microsoft kind of ecosystem, but these concepts can be applied to lots of other databases and query languages. So if you're not aware, there's this really cool tool that's free. It's a desktop application that's free for anyone to download. It's called Custo Explore. It's a desktop app that has a lot more kind of features in terms of like query interface, like lots of different types of highlighting and conditional formatting and things of that nature. And they have this extra handy dandy feature that enables you to kind of render and make graphs. And there are a few operators to make graphs out of your Custo data and query it. There's this whole like pop-up window that enables you to query the graph, have conditional formatting, have icons for nodes and things of that nature. And so it turns out that if you have data right now in a Sentinel Log Analytics workspace and you have the Defender XDR connectors into your Sentinel Log Analytics workspace, you can connect to the same data that you already have in Custo Explorer with the link at the bottom. The same data that you already have, you can view and query with this tool that's available out there for free and start making graphs with this operator. And so this is an example of makegraph, the main operator that's used to construct these knowledge graphs in Custo Explorer. Traditionally, it's super, super useful. Traditionally, you have to kind of manually mint nodes and edges with a bunch of let statements. So for each and every single node and edge type you have to have a let statement. And this enables you to make knowledge graphs pretty quickly for smaller, more simple knowledge graphs. But as soon as your graphs get more complex, as soon as you want to change your model, I mentioned earlier that a lot of security activity graphs, you might want more kind of malleable modeling. As soon as you want to change up your model, you have to rewrite all of your let statements. And this gets super cumbersome and tedious. I've written make graphs statements that are like hundreds of lines long. And this is not really a priority for SOC analysts or investigators. They're already knees deep, knees in the weeds, trying to investigate tons of different alerts and investigate all these different threat actors. They're not really willing to spend the time to break out to just make a graph with this really long KQL statement. And so to tackle this problem, we've made a few more generic Custo functions that wrap some of the complexities and the redundancies of makegraph. So essentially, given the results of any KQL query that you already have now, and a JSON mapping of the node and edge types that you have and the columns that represent those node and edge types, you immediately have a knowledge graph representation of that same query result. And so that's lift to graph, and then graph render view actually renders your graph. And so this JSON object is something that you can save off on your cluster, your database in Kusto, so you can reuse them. And so this is an example of one of them. There's node types and there are edge types, and those are the key and the props are the columns that map to the unique identifier of your node and edge types and the properties on those node and edge types. And then you can also define icons to be your nodes as well in your graph, so it's a lot easier to orient yourself around the graph by using visual cues that match what you're already familiar with in whatever data world you're in. So for example, we use the official Azure icons as node types, so folks can easily orient themselves in the data that's being represented in their graph. And so we've open sourced, we've released on GitHub a few of these functions that we've created. Lift to graph, like I mentioned previously, takes in the output of a KQL query that you already have in the JSON mapping for that same KQL query. It transforms it into a table of nodes and edges, but it does not actually render or call make graph just yet, because you might want to do a few other operators and transform that table of nodes and edges in different ways. And one of those ways could be this thing we call graph fold. And what this does is it essentially collapses common nodes that have the same property value of the same entity type into one Uber node. So an example is if you have like a bunch of IP address nodes scattered across your graph and you want to see, okay, what are all the IP addresses of like X carrier, like the Amazon incorporated carrier doing? You can collapse it into kind of one Uber big node and all the edges will rewire. This is kind of a similar view as like as group by in KQL, if anyone's familiar. And then graph render view at the end actually renders your graph. But you can imagine a bunch of other Kusto functions that do other operators to your graph that could enrich your nodes with different data sets that are in different tables and can kind of transform your graph in different ways while you're investigating. And so for the purposes of this demo, we're really showcasing the KC7 data set. This is a super awesome project for folks to learn more about, security logs and how to query and find and investigate different threat actors in your environment. So synthetic open source data set, and it's been super, super useful for the purposes of our open sourcing these functions. And so this on the screen is kind of a run through. This is Kusto Explorer, the tool that I mentioned previously. On the left here, we have the KC7 open source data sets, and this is an example of one of the lift to graphs that we have. As you can see, instead of like hundreds of lines of KQL manually minting all these nodes and edges, it's just a few function calls. You have your mapping JSON, which again you can store off on the cluster and call as a function. And then we call that KQL query, we call lift to graph with the JSON mapping and graph render view. And now just with a few lines of Kusto, of KQL, you have this kind of graph authentication event graph spun up. And so this can enable analysts to make these graphs a lot easier at the language that they're already familiar with the data sets that they already know, with this tool that's already free and available for anyone to download. And just at a glance, you can kind of start to investigate this data and see the different kind of structures and shapes that stand out to you. For example, these smaller subgraphs are benign sign-in events, but there's this kind of giant, huge network in the middle that's kind of the interesting bit for this particular KC7 investigation game. And you can interact and see the properties of these nodes. You can query on the right. This is a different graph that we have. This is just a take 400 of email events. And again, just with a few function calls, you have this graph constructed for you of different email messages being sent between different email addresses. And then in Kusto, just like how you can union tables of data, you can also union graphs together. The same, again, they're just, at the end of the day, tables of nodes and edges. And so what you can do is that if two nodes have the same unique identifier, make graph will just pick one of the two nodes randomly, and we have a function to dedupe, within lift to graph, dedupe the two nodes and bag up all the properties so you don't lose any. And so now you can start investigating and poking around the union graph. So you can imagine, like, if you have a bunch of hunting queries that you have, or a dashboard of hunting queries that you usually run when you're investigating, you can kind of have your mappings created, union them together, and start to have an investigation graph that then you can do things like graph fold by property, which I mentioned earlier. So the email messages have labels as to whether or not they're blocked or suspicious or clean. And so here we're folding the email message nodes by their verdict. And in Kusto Explorer, you can define the size of your nodes to be by a particular parameter. Here we're defining it to be by how many nodes are folded to create the Uber nodes. And here, this one stands out. These are all the email messages that were labeled as clean. So there's 100. We keep all of the folded nodes defined as one of the properties on this Uber node. And then you can run graph queries. Here on the right, we ran a graph match on looking at paths that are like 3 hops away from these different folded nodes. So here we can start to threat hunt and see, or investigate and see, okay, what sign-ins to users around this time led to them receiving some or sending some email that was blocked within their organization. Pretty relevant for this particular KC7 game. And so these are the sorts of graphs that we can construct by just making a few simple Kusto functions that wrap some of the complexities of MakeGraph that really uses this free tool that already exists from data sets that analysts are already familiar with and a language they're already familiar with. And so, one of the key takeaways that I have from this experience is like, there's, with AI and code-gen agents, there's this huge like hype to build everything and build new solutions to fix every single problem. And when I was first kind of tackling this problem and thinking about it, I was like, okay, I need to build like 50 different data connector, ETL pipelines, and spin up these graph databases and load up these things. But we've been able to find a lot of impact and get actually a lot of analyst usage of these graphs by just meeting analysts where they are and the query language they're already familiar with over the data sets they're already familiar with. And it's a lot easier, like I mentioned previously, to orient yourself on a graph of data that you've created yourself on a schema that you're already familiar with. And so that's all I had for today. Thank you so much for your time. Does anyone have any questions?
Well, first of all, maybe I can kick it off. Also, I could turn on the microphone. Testing. I don't know if I'm on. Okay, great. Oh, there we go. I'm wondering, like, when you're working with the analyst teams, like, I found that often, some people are already trying to do graph stuff and like they're happy to like, oh, great, this just makes it a lot easier. And like, that's our favorite case, right? But sometimes there's other people who haven't been doing this stuff. And so as you've been like, I hear what you're saying about meeting them halfway of like, okay, they're already doing Cousteau, or let's just and maybe the initial language is weird. Let's make it a little easier. But like, do you feel like there's like any patterns you've seen of like what makes the ahas like, oh, there's a certain kind of graph or certain kind of use case or anything that you've noticed makes it easier? Yeah, totally. I think showing graphs, I mentioned previously that the graph data structure enables you to ask questions because of the specific operators that you can only apply to knowledge graphs. So showing examples in which, hey, this query would have been like 100 lines long in KQL, and you would have to do like 5 joins and like crunch all this data. This is an example of that same question being answered as like a graph query instead, and look at how much simpler it was to write. So stuff like that of just showing them like how much easier certain parts of their jobs will be if they answer these questions in terms of graphs instead. Do we have any other questions for our speaker?
Cool. I've looked some at the KC7 data, and I was curious what other data sets, public data sets, are out there that you recommend that you guys are using or presenting on. If there's other good cyber ones. I mean, the Sentinel graph is about to. That's also kind of a. It's going public this week, right?
Yeah, Sentinel graph, they got tons of cool features coming out. I think they're releasing this week. In terms of the public synthetic data sets, KC7 is the main one that I've interacted with, but we just had a whole awesome presentation today on other data sets too that aren't just Azure or Microsoft specific. So there's tons out there.
Well, maybe flipping around, which one would you like to see? If there's any, like, oh wow, I'd love to have a data set like this, because
multi-tenant data sets would be interesting. I don't know. I'm coming out from Microsoft where we have tons and tons and tons of tenants. So like lateral movement across tenants is something that we're really interested in, and something that I haven't seen a lot of synthetic data sets really focus on, but that might just be a big corporation problem of having tons of tenants and less of, so. Cool.
Well, yeah, so she'll be around after if you have more